Welcome to today's briefing. As theoretical physicists, you're all too familiar with the massive headaches the Standard Model is giving us lately. I mean, between the Hubble tension and James Webb constantly throwing fully mature galaxies at us from the dawn of time, we've got some explaining to do. So in this explainer, we're going to dive into a brand new, incredibly parsimonious alternative by George Jesse Woolridge. It's called dilation flooding. And a core idea? Stop treating time dilation like a static backdrop and start treating it as a dynamic propagating phenomenon. It's an absolute game changer for cosmic evolution.
Here is our roadmap for today. We'll start with the historical baggage of Standard Model tensions, move to the causality of gravity, define the last undilated horizon, break down the temporal integration mechanism, see how it resolves our current anomalies, and wrap up with a look at a far more parsimonious universe. Let's get right into it.
Part 1. The historical baggage we're still dragging around in our standard models. You know, it's pretty wild to think about, but our foundational theories were actually born during a time when everyone, literally even Einstein and Hubble themselves, just assumed the universe was static and eternal. They were super reluctant to accept the idea of a finite-age universe, even when their own math was screaming it at them. Because of that old eternalist mindset, we inherited this weird legacy of treating time dilation and gravity as if they are permanent static background conditions, rather than effects that actually propagate and evolve over time.
And that leaves us with the stark contrast we face today. On one side, you've got the lambda CDM model. Now, to make lambda CDM work, we have to patch it with exotic, completely unverified placeholders like dark matter and dark energy, and we just assume gravity equilibrated everywhere instantly right after the Big Bang. But on the other side, we have the dilation flooding model. It is radically parsimonious. It relies solely on the established rules of general relativity, the reality of a finite-age causality, and the proven homogeneity of the cosmic microwave background. No exotic phantoms needed whatsoever.
Moving on to Section 2. Let's trace how our understanding of gravitational causality has evolved.
We all know the historical progression, right? From Newton's inverse square gravity to Einstein's GR, up to the discovery of the CMB, which proved we live in a finite universe with an electromagnetic causality horizon. But here is the absolute clincher for today's briefing, the LIGO GW17-0817 multimessenger event. That neutron star merger definitively proved that gravitational phenomena propagate strictly at the speed of light. Gravity shares the exact same causality limit as electromagnetism.
So think about what that means. If light is constrained by a causality horizon, why on earth do we model the gravitational field as if it equilibrated everywhere instantaneously since the Big Bang? It's a massive logical contradiction. Woolridge argues, and I think he hits the nail on the head here, that the burden of proof is heavily on standard models to justify treating gravity as a static, globally equilibrated field.
Which brings us seamlessly to Section 3, defining a highly parsimonious new boundary called the last undilated horizon.
Okay, so just like the cosmic microwave background has a surface of last scattering, the absolute limit of our electromagnetic observation, we have to apply that exact same logic to gravity. We must define a last undilated horizon. Picture an expanding boundary that perfectly matches the age of the universe. Beyond that boundary, the gravitational tug from distant mass shells literally hasn't had enough time to reach us yet. But as that horizon expands outward at the speed of light, the dilational effects from those distant shells finally hit us, creating a cumulative background time dilation field. This right here is what Woolridge calls dilation flooding.
Now for Section 4. Let's clearly deconstruct how this temporal integration mechanism actually works in plain English.
Let's use a really simple analogy. Think of it like adding continuous layers to an onion over billions of years. Step 1, our gravitational causality horizon is constantly expanding outward at light speed. Step 2, as it expands, new spherical shells of mass from our homogeneous universe are newly added to our observable causal sphere. And step 3 is the elegant part. The gravitational pull of each new shell drops off due to the inverse square law, right? But the volume and therefore the mass contained in each new, larger shell grows with the square of its radius. These two mathematical realities perfectly cancel each other out. The result is a perfectly linear, relentless increase in the background gravitational potential over cosmic time.
And why should we care about that linear increase?
because this simple integration yields an ambient gravitational expansion pressure that perfectly matches the exact, minuscule local value we observe for the cosmological constant, 1.465 times 10 to the negative 52nd per square meter. By treating expansion as a dynamic dilational effect, this model cleanly sidesteps the famous lambda CDM vacuum energy catastrophe. You know, the one where the standard model prediction is off by a staggering 55 orders of magnitude? Just a tiny miscalculation, right?
All right, section 5. Let's see how this dynamic framework resolves our biggest cosmological tensions.
When we replace static assumptions with dynamic temporal integration, our worst edge cases start to systematically solve themselves. Instead of duct taping the Hubble tension, James Webb's early galaxies, or weird galactic rotation curves with new exotic particles, dilation flooding resolves them all purely as natural consequences of a time-varying gravitational potential. Let's break a couple of these down.
First up, James Webb. Why is it finding fully mature galaxies so early in the universe? Well, while time dilation looks linear locally, over vast cosmic distances, it is fundamentally hyperbolic. When we integrate this across the cosmos, we hit the knee of that hyperbolic curve, which creates an excess of spacetime curvature at extreme distances. Because of this excess curvature, incoming light is disproportionately delayed. That means those mature, high redshift galaxies are actually significantly closer to us and, crucially, hundreds of millions of years younger than their raw redshift suggest. Just like that, the tension vanishes.
And what about galactic rotation curves? The standard model injects dark matter to explain why the outer arms of mature galaxies are spinning way too fast for Newtonian physics. But dilation flooding shows that this extra mass is just an illusion born from static modeling. Over billions of years, the expanding last undilated horizon shifts the entire background potential lower, causing the galaxy to relativistically fall. This continuous historical frame dragging alters the dynamics exactly as if you had added invisible mass to the system. It effortlessly mimics dark matter.
We see the exact same thing with the bullet cluster, which people love to cite as the smoking gun for dark matter. But think about it. The X-ray snapshot of the gas distribution is just a momentary glimpse. The lensed photons from background galaxies took 9 million years to travel through that evolving cluster. Over a 9 million year transit, the cluster's local potential deepened and its structure evolved. So that famous offset? It's not a clump of invisible exotic particles. It's just the historical frame-dragged curvature that accumulated while those photons spent 9 million years navigating a dynamically changing dilational field.
Finally, let's wrap up with Section 6, applying Occam's razor for a more parsimonious universe.
The theoretical parsimony here is just undeniable. The dilation flooding model doesn't ask us to invent anything new. It relies purely on 3 rock-solid established facts of physics: a finite-age universe, the causal speed of light propagation of gravity confirmed by LIGO, and the immense homogeneous of the universe confirmed by the CMB. By simply acknowledging that gravity takes time to cross the cosmos, we completely eliminate the need for arbitrary metric expansions, dark energy, or exotic dark matter. The math just works out. So, as theoretical physicists, I leave you with this final question to ponder for your own research. Do we really want to keep adding increasingly complex, unverified phantoms to patch our static standard models? Or is it finally time to let gravity act at the speed of light and integrate time dilation dynamically to match the true causal nature of our universe?